Hello again. This video is really only for the Regents physics students, but conceptual students, obviously, you can watch if you're interested. It's just going to be a little bit of calculations involving an equation that conceptual students are not responsible for. But here we go. We're getting into the Coulomb's law equation again. Um, I want you guys to think about what would be the amount of force if we had two positive charges of 1 coulomb each, if they're 1 meter apart. So I'm making the numbers all one to make it easy. You got 1 coulomb over here, 1 coulomb over here, 1 meter apart. How much force is acting between them? Well, just go back to the equation if you need to. The equation for electrostatic force, also known as Coulomb's law, is you take the two charges, multiply them together, divide out the distance between them squared, and then multiply that by the K constant, the Coulomb's law constant. So if each of the Q values is 1 and the distance between them is 1, well, then there's really only one number in this calculation that gives us any value, and that is Coulomb's constant. So just as this very easy example, hopefully you saw this before I said it and showed you the answer, 1 coulomb and 1 coulomb separated by 1 meter, there is 8.99 times 10 to the 9 newtons of force between them. That is a tremendous amount of force. We're talking in the realm of trillion newtons. Extreme amount of force. That is why 1 coulomb of charge is an extremely high amount of charge. Very unrealistic for an object to have 1 coulomb of charge. Almost always it's a very small amount. That's why a lot of the times in problems you might see the prefix mu, which means micro or times 10 to the negative 6 coulombs. That is a more realistic amount of charge an object will have. But I like Regent students to try another problem. This involves the amount of force between protons and electrons, both with their electrostatic and with their gravitational interactions. So let's say we have a proton and an electron separated by 1 meter again. So the R value in the equation is 1. But now I want you to calculate the gravitational force instead. Now, of course, here I wrote them out for you in case you've forgotten. The gravitational force has our gravitational constant multiplied by the two masses and then divided out by the distance of separation. So for this, you're going to need the mass of the proton and the electron. Fortunately, you have that in this presentation if you flip back to the beginning, or you have it in your reference tables. And then after that, I'd like you to calculate the electrostatic force between a proton and an electron separated by 1 meter. So again, now we're looking at the electrostatic force, which looks extremely similar. It's got a different constant. It's got charge multiplication rather than mass multiplication, but still got the same distance of separation inverse squared relationship with the force. So hopefully you noticed that before I just showed it to you. The M values and the Q values and the G and the K's, those are different numbers, but the setup of the equation is very similar. I'd like you to calculate both the gravitational force and the electrostatic force. Use M's and the G here, use Q's and the K here, with the same R for both, and I'd like you to see the relative amount of force between the proton and electron in either case. And you can save yourself some trouble by storing some of these numbers in your calculator. This problem is part of the problem set I left only for the Regent students, the Coulomb's law questions. So you can put down your answers on that assignment after you do this calculation. See you guys in the next video.